Okay team, so here we have question 3 from your test, and we have to show that dy dx, or the gradient function for this curve, is always negative. So obviously our first step in that is to do dy dx and find what that is. Now we are needing to use the quotient rule since we have u divided by v here. So let's just do this. U is equal to 1 plus e to the minus x, and therefore du dx is going to be equal to, well, that drops out and we'll end up with minus e to the minus x. Now we do the same for v, which is our bottom one. 1 minus e to the minus x. So therefore dv dx is simply going to be, well, this drops out. Minus 1 times minus 1 is positive, so it'll be e to the minus x. And we use the product rule, so at this point we're going to go dy dx is equal to v times du dx minus u into dv dx. So all over v squared, this one here squared, so that's the start. Okay, now let's expand out our work here. So what do we end up with? Negative e to the minus x plus e to the, at the powers, minus 2x minus e to the minus x plus e to the, minus e to the minus x times 1. So minus e to the minus 2x all over 1 minus e to the minus x all squared. Gather our like terms here. This is going to cancel out this. And so we end up with minus 2e to the minus x all over 1 minus e to the minus x, and that is squared. Okay. Now if we consider our graph of e to the x, it's very close to the x-axis here, and then you see it goes like this. So e to the power of negative x is going to be a small but positive number. When we multiply that by minus 2, we will get a small negative number. The bottom, whatever you get here, is in this bracket here is squared, so that will also be a positive number. So you can see that this is always going to be a negative number, and we would need to say something like, since the bottom is always positive and the top is always negative, then we will always have a negative gradient. Okay, I hope that makes sense. That's the first part of the question. Now for part 2 of this question, we are told that when x is equal to a, the gradient is equal to minus 1. So I'm just going to change my x's to a's. My next step will be to pull this across over to this side. This may or may not be the easiest way to do it, but I'm going to do it anyway. I'll put a big square bracket here and I'm going to expand this. It will be 1 minus 2e to the power of minus a plus e to the power of negative 2a. Hope you can see why that is. Using FOIL with this bracket, and then we're going to multiply everything out by minus 1. So now our next line will be negative 1 plus 2e to the minus a minus e to the minus 2a. Now at this point we can pull everything across to one side. I'm going to pull it all over to this side. I think that's probably what would be best. So if I pull this across over to here, I'm going to have e to the power of negative 2a. If I pull this across, this is going to add with this. This will become minus 2, so we'll end up with minus 4e to the minus a. And pull this across, which is a minus 1, it becomes a positive 1, and we end up with 0. Now, is that what we're trying to prove? No, not quite. Okay. At this point, I'm going to times this whole equation by e to the 2a. This term becomes 1. This term becomes 4e to the a. And this becomes e to the power of 2a. If you're not quite sure what I've done here, just use your index rules. We've got base e here to the minus 2a. We add the indices if the bases are the same, so that's e to the 0, which is 1. Okay, so now I have things, and that's equal to 0, in the format that is required by the first part of the question. Okay, at this point we need to look at this as a quadratic, and I'm just going to say I'm going to put this as let's over here just say that e to the a is going to equal x, and we'll just put it in a form that you're more familiar with. So e to the 2a is therefore x squared minus 4x plus 1 equals 0. So I hope you can see we can now solve this by quadratic formula. X is equal to, in other words, e to the power of a is equal to minus 4, minus b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. What does this equal? Well, this is going to be 4 plus or minus the square root of 4 squared is 16 minus 4, so the square root of 12 over 2. And this is going to be further simplified 2 plus or minus the square root of 4 times the square root of 3 over 2, and these are going to cancel out, so it'll just be plus or minus square root 3. Okay, so I hope you are following me to this point. So now we're at this point here. E to the a is equal to 2 plus or minus square root 3. Let's consider the first one, plus. How do we get a by itself? We take the log of both sides. So a, the natural log, is equal to So how do we decide what our final answer is? Because you can see if you look at the paper, it says that you have to find the exact value of a, and we have two values here. The answer is, and I had a little bit of a struggle with this for a little while, the answer is, of course, as Pakawat would say, read the jolly question. And it says that this curve is for x is greater than 0. So therefore, given that a is a value of x, a must also be greater than 0. And only one of these gives you a value of greater than 0, which is ln 2 plus the square root of 3. So just a hint there, read the question. That was where I went wrong on this one when I first tried it. Hope that helps. Good luck with your practice.